Warm greetings to all who are tuning in to this session. This is the second session that we are conducting in basic algebra to the juniors who are planning to participate in the South African Mathematics Olympiad, round 2. We did some problems last time and we tackled various topics, amongst them solving of equations, a little bit of inequalities, and so on, counting. And today we are going to continue in the same vein. We may introduce a few other topics as well. So with that background, we go straight away to the first problem that we are going to look at. This problem reads, PQRST is a 5-digit number. Each group of 3 adjacent digits has a sum of 12. Each group of 4 adjacent digits has a sum of 17. What is the sum of all the digits? So let's draw a diagram here first. So I've drawn this block, and these represent the 5 digits of this 5-digit number, PQRST. It is given that each group of 3 adjacent digits, adjacent means next to, like these 3, for instance, they will add up to 12. So let's just take that. They add up to 12. Each group of 4 adjacent digits has a sum of 17. So if you take those 4, for example, you'll get 17. So if these 3 add up to 12 and those 4 add up to 17, it means that this last digit here must be 17 minus 12, which is 5. See? And likewise, you will see that these 3 digits add up to 12, and those 4 digits add up to 17. So this will also be 5. Okay. Now, since the sum of 3 digits is 12, and you already have 5 and 5 here, so this has to be 2. And here you got 5 plus 2 is 7, so this has to be 5 to make 12. And likewise, this is 12. So we have all the 5 digits, and we can see the sum of all the 5 digits. That's a question that is asked. What is the sum of all the 5 digits? The answer is 22. Before we go into the next problem, let me say something about factorization. So what do we mean by factors? Like we know we can take 40, and 40 is equal to 4 times 10. So we say that 4 is a factor of 40, as we got here, and 10 is also a factor of 40. So every time you write a number as a product of 2 numbers, as we've got here, then each of these numbers is a factor. A equals BC, a number written as a product. This is the product. B is a factor of A, C is a factor of A. Now, in fact, every positive integer can be factorized into prime factors. Right. Now, what is a prime number? A prime number is a number which cannot be factorized. Cannot be factorized any further. Like 4 is not a prime number because you can write it as 2 times 2. But of course, every number can be factorized, like P equals P times 1. You can write it like that. But we are not counting these. So except for this factorization, a prime number has got no other factorization, right? And for example, if we say, if you look at this side here, suppose we say factorize 60 into its prime factors. We claimed here that every positive integer can be factorized into prime factors. Let's try to do that to 60. So the way to do that is you take 60 and you take the first prime number, which is 2. You can see 2 goes exactly into this. So you divide 60 by 2. 2 goes into 60 30 times. Now you look at this number. That number, 2 also goes into that, and 2 is a prime number. So 2 goes into that 15 times. Now this number is odd. 2 does not go into this. But the next prime number is 3. And that certainly goes into this 5 times. And now, at this stage here, 5 is a prime number. It can't be factorized any further. The only factor is 5. So you put on 5 and you land at 1. So the moment you land at 1, you can now say that 60 has been factorized. And the factors are precisely 2 times 2 times 3 times 5. When you multiply these 4 numbers, you will get 60. 60 is equal to that. But if you notice, you can group together the 2's. 2 times 2 is 2 squared. So you can write this as a power of 2. Right? Or you can write this in exponential form, if you like. So the power of 2. And there are no other 3's, so you got 3 and 5. So eventually you have that 60 is equal to 2 squared times 3 times 5. So this becomes now a factorization of 60, right? And we can write it as a factorization to prime powers like this. This is a factorization of 60 into primes. And here, when you group them together, then you can write it as factorization into prime powers. So, in fact, in general, every positive integer n can be written as a product of prime powers. Right? N can be written as a product. And this is rather complicated, yeah? But this is a prime power. The base is a prime number, and this is the number of times the prime number goes into this. Like 2 went into 60 twice. So n1 is that number. And you can write it as a product of numbers which are just got all the bases of prime numbers. So let's look at problem number 2. What is the largest integer value of x such that 4 to the power of x is a factor of the product 1 times 2 times 3 times 4 times 5 times 6 times all the way up to 10. Right, so you want 4 to the x to be a factor of that big thing there. So it means that we have to factorize this one. And one of the factors will have to be 4 to the x. So we want to write this as 4 to the x times something first. And x cannot be larger than that. It must be the largest possible value. So to do that, let's factorize this number into its prime factors. So this is what I've done here, right? You can see I've written this on the left-hand side. Equal sign, this is equal to, right? Now I write down all the numbers, repeat the numbers, but 4, in place of 4, I put 2 times 2. So I'll factorize each of these numbers which are not prime. 2, 3, 5, they are not prime. 6 can be written as this. 7 is a prime. 8 is 2 times 4, which is 2 times 2 times 2. Right? So I've replaced 8 by that. I've replaced 9 by 3 times 3 and 10 by 2 times 5. So now you've got this is a product of prime numbers. None of them can be factorized any further. And if you group the 2's, you will get 2 to the 8 times 3 to the 4, 5 squared times 7. Right? You can do that quickly. Now you see the largest power of 2 that can be taken out is 8. You can't take out any 2's from here, right? Now, but we want to take the largest power of 4. So what is 4? 4 is 2 times 2. So let's write 2 to the 8 as only 2's, right? And leave the other intact, and we are concentrating on 2 to the 8 now because we're looking for a power of 4. And then if you group them together, the 2 2's here give you 4, another 2 give you 4, and so on. So there are 4 groups of 4 here. 8 groups of 2, but 8 2's, or which is the same as 4 4's, right? Because each 4 occurs twice. So you got 4 to the power of 4, 4, 4, 4, 4, and then you have an odd number. So the largest power integer value of x such that 4 to the x, this 4 to the x is a factor is 4. So that is the x. You can't make this any larger because this is an odd number, so you cannot take out 4 from that. Problem number 3 states, what is the difference between the largest and the second largest odd factor? So you're looking for odd factors, you want the largest odd factor, and you also want the second largest odd factor, right? So of 2016. So let's factorize 2016 as a starting point, like the way we did before. So you start with 2016, and you see that this number is even because the last digit is even. So you can divide by 2. And if you keep doing that, you'll see the last digit is even each time. So you can continue to divide by 2 and get an answer. And then when you come to this, now this number here is odd because the last digit or the units digit is odd. So you abandon 2 now, you get to the next prime number, which is 3. 3 goes exactly into this because 6 plus 3 is 9. And it goes into this 21 times. And 21, 2 plus 1 is 3. And 3 goes again into that. You come down to 7, and 7 is a prime number. It stops there. 7 goes to 7 one time. So if you group all these things together, you get 2016. This becomes the factorization, right? And you're looking for the largest odd factor. So this part here is an odd number. All the 2's have been removed there. So this becomes the odd number. And obviously, this number here, right, which is 3 squared times 7, that is the largest odd factor. It's a factor because 2016 is equal to that multiplied by this. You can put this in brackets, right? So this is a factor, and this factor cannot be any larger, the odd factor, because otherwise you'll have to take one of the 2's from there to make it larger. But the moment you take a 2 from there, this thing now becomes even. Right? So this is the largest odd factor. That number is 63. 9 times 7. So the largest odd factor is 63. Now what is the second largest odd factor? So if you take 63, you want to take its largest factor, apart from 63, and you will see that you have to remove the smallest factor from 3, and you get 3. 63 equals 3 times 21 to get the largest factor. So the second largest factor is 21. And you want to, well, the question is, what is the difference between these two? So it's the difference between the largest and the second largest. I'm sorry, it's 21. And that gives you the answer of 42. This is a good example of where you have to read the question carefully and try to understand it, right? But you have to do it piecemeal. If you just read it just like that, it becomes very complicated. So remember, you work out the difference between the largest and the second largest odd factor of 2016. So you start with factors of 2016 and you look for the largest odd factor of 2016, which we saw was 63. And then you look for the second largest odd factor. And this thing here tells you how to get the second largest odd factor. And you subtract those two because you want to find the difference. That gives you the answer.